Okay, ladies and gentlemen, good morning. Can you hear me? Am I coming in loud and clear? Let me know in the chat, people. Smash that chat button. Hello, Steve. Good to have you with us. Um, how was lab test one? I've put a little poll in the on the screen. So 15 people have said good, no surprise questions. 7 people have said no surprise questions, but I got them wrong. Oh no. 4 people said they haven't done the test yet, and 3 people have said what test. Remember, you have a lab test. It's open right now. Anyway, let us know what's happening with your lab test in the comment section. Remember, a few people have not done the test yet, so don't give too much away if you've already done it. Okay, so in today's lecture, we are going to look at curve sketching. Okay, so curve sketching is something that we can do pretty easily with Maple or GeoGebra, but it's still nice to know what graphs should look like and have some basic techniques for understanding them. So that's the idea of today's lecture. So let me move over to my document camera, and this is what we're going to do. We're also going to look at these odd and even functions, right? So we say that a function's even if it has this sort of algebraic relationship, if you like. Now, there is an easy way to understand even functions when you like a geometric way, but this is what we can start with. And you can talk about an odd function, f of x equals negative f of negative x, or if you want to put the minus sign on the other side, that's fine too. Okay, so we'll talk about these concepts a little bit, and we'll also look at examples. Now, some of these examples will probably be familiar to you from previous studies or school or something. But if you've forgotten, then that's fine. Okay. All right. So these are handy little things that can save you time when you're sketching the graph of the curve. All right, so basic strategies. These are some of the things we're going to use: odd and even functions, asymptotes, stationary points. We're also going to use limits, and things like intercepts. So where does the graph cut the x-axis and the y-axis and stuff like this? I'm going to spend a little bit of time talking about shifting simple curves. So I'll do an example where you actually have some sort of difficult curve to sketch, but by sketching simple curves and shifting them around, you can get the more difficult curve. So this sort of thing doesn't involve any kind of calculus, right? All right. So we're going to, like I said, talk through some examples. But before we get there, let's talk about this odd and even functions first. Now, this is the sort of formal definition. So we talk about a function being even if f satisfies this, right? And a function is called odd if f satisfies that. So, like, sure, these are algebraic concepts, but what do these things actually mean? Well, I find it's very helpful if you can draw a picture with these things, right? So let's have a look at x squared. Okay, it's a really simple graph. And I'm going to draw half the graph, right? What this algebraic condition says is that you can take all these points and reflect them in the y-axis. So you take those points, you reflect them over here, and you get the other half of the graph. Okay, so that's what we talk about when that's what we mean when we say a reflective line of symmetry. Okay, you can plot this graph, reflect it over through the y-axis, and you get the other half of the graph. Okay, what about another one? Well, negative 2x to the power 4. Well, you can draw that. It's going to look something like that. And you just reflect the other half over. Cosine x. Okay, well, for this one, you've got something like that, where this might be 1 and this is, negative 1. And then you just take it and you reflect it over to the other side. Okay, so that's a really good way, in my opinion, of really understanding what an even function is all about. Okay, now with odd functions, it's a little bit different, but there's still some symmetry there. Okay, and the idea can be explained through rotation. So let me draw a graph, and then you can see what happens, right? So let's draw x cubed. Okay, it's a pretty familiar function. Something like that. Okay, so the best way, in my opinion, is to rotate the whole graph 180 degrees, and you still get the same shape, right? I'm ignoring the axes here, but you still get the same shape of the curve. Okay, if that's true, then the curve is, or the function is, odd. Okay, so with this one, it's reflection. With this one, it's rotation. Okay, so let's do another one. I'll just show you sine of x. So sine of x, I guess, can look something like this. That's just part of it. Now, if I take this and I rotate it 180 degrees, it's the same curve, right? So yeah, there are some basic examples where you're drawing curves, you can reflect them or rotate them. Okay, so why is this actually helpful? Okay, so for me, it's helpful because if you're asked to sketch a curve and you know it's an odd function or an even function, then all you really need to do is sketch half the curve. Why? Because you get the other half for free, right? You get the other half for free. Okay, sweet. So work harder, not smarter. I mean, smarter, not harder. Lol. All right, so let's dig down a bit more into this odd and even function and see what we can see. All right, so with these ones, it's pretty easy to work out whether they're odd or even, but sometimes we'll get a function like this one, and it's not clear whether this is odd or even. So it's pretty easy to work it out. So if you have a pair of odd functions and a pair of even functions, and you multiply the two odd functions together, you get an even function. So odd times odd gives you an even function, right? So there's various different combinations here that you can look at, right? So so let's say f and g are odd. So odd plus or minus odd gives you an odd function. All right, and there's other ones as well. Okay, so whenever I do a video like this and I put it on YouTube, people always argue with me about these because these don't work necessarily when these functions are just numbers, right? So I'm not talking about numbers here necessarily. I'm talking about functions. Okay. So with this one, odd times even equals odd. And for this one, even times even equals even. Yeah, people troll me all the time when I do something like this on YouTube. They're like, "No, Professor, you are wrong." Yeah, that's right, Matthew. People will argue. The trolls come out when they say, "Ha ha! I found two numbers that don't satisfy this. You are wrong, 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 Professor." Oh no! Help me! Yeah. Anyway, so people argue in the comment section for hours on YouTube about it. Anyway, let's have a look at these things and see if we can test out our knowledge, right? So this one, well, we're not multiplying there or anything. Cosine is, who can tell me what is this odd or even, the first function? It's got nothing to do with what's up here, but who can tell me? Is the first one odd or even? Who can tell me in the chat? Any ideas? What's the first one? It is even. Thank you, Nicholas. Thank you, Michelle. Michelle? Let me know if it's Michelle or Michael. What about this one? This is an odd function times an odd function. Yeah, Nicholas, odd times odd gives you an even function. Okay, thank you. What about this one? Cos squared. Cos is an even function. Ah, Michael, excellent. Hi, Michael. So you've got, this is even times even. Even. Okay, what about this third one? I know, Matthews. Okay, it's an odd function minus an odd function. So we know it's going to be odd. Okay, now we'll look at this in a minute. The reason that this is important, if we're going to sketch this graph, we can really just sketch half the graph and then rotate it 180 degrees. Okay, so brilliant, right? So if I wanted to put in a little bit of extra thing, this is odd times odd. Okay, x is an odd function, sine x is an odd function. This is an even times an even. And this one is odd minus odd. Okay. Oh, Serena, yes, you can have functions that are neither. Great question. Thumbs up. So you can have a function that's not odd or not even. Okay. So they don't satisfy any of these properties. Okay. All right. So don't be fooled. Sometimes functions don't have any of these properties, right? Do odd functions have symmetry around the line y equals x? No, not really. Well, what do you mean symmetry, Michael? Do you mean a reflection? Because if it's a reflection, it's not true. I think they'd have the reflection if you're looking at the inverse function. Is that kind of what you're meaning? I just look at it as a rotation about the origin of 180 degrees. No, I don't think that, no, because if I draw, that's a good question, Michael. If I draw in the line y equals x, it's not reflected in the line y equals x, right? That's definitely not true. Okay. Yeah, Matthew, they should. Do all functions have an intercept at the origin? Yes, they should. That's if they're defined at the origin, right? Sometimes you'll meet some functions like this one, like a step function. Technically speaking, that's odd, but it's not defined at the origin. Okay, so that's a good question, Matthew. So in this case, it doesn't have to go through the origin, but for nice friendly functions that are odd, they all will go through the origin. Does that make sense, Matthew? Let me know in the chat. Yeah, we're asking the good questions this morning. I'm impressed, everyone. Okay, so let's have a look. This is definitely an odd function because x cubed is odd and 2x is odd, right? So this is like an odd function minus an odd function. Gives you an odd function, right? So we kind of know what this will look like with symmetry. If we draw half the graph for x greater than 0, I just rotate that about the origin to get the other half. We get the other half for free, okay? And so what I can do is simplify, the expression so I can find its intercepts. Something like that. So I know it's odd. I know it cuts the intercepts of the horizontal x-axis at 0 and plus or minus √2, right? I know that, what else? What is this function doing as x gets large and positive? Who can tell me? What is the limit? What is f of x approaching as x approaches positive infinity? Who can tell me in the chat? Matthew, absolutely. It is infinity, right, Steve and Matthew? And what about as x approaches negative infinity? What is f of x approaching there, people? Who can tell me? Negative infinity, exactly, Carl and Steve. Okay, so we kind of know that as we go out, as x becomes positive, the graph goes sort of off towards infinity. As x gets large and negative, the graph goes off towards negative infinity. Okay. All right. So let's start sketching our graph. Okay. I know it sort of comes up there and there. It has an intercept at √2, negative √2 and 0, because when x equals 0, y will also equal 0. And so it's a nice friendly function. And so what I'm expecting is the graph will sort of go down there, come up here, turn around, and then go up like that. Now that would definitely fit with the odd property of the function, because if you do that and you rotate it, then you get exactly the same graph. Okay, so I guess the last thing to determine is where the derivative is 0. So let's differentiate it and use some calculus. So if I differentiate this, I'll get 3x squared minus 2. And I know that if I set that to 0, then I can find my stationary points. Okay, so if I take the 2 to the other side, that's going to be the location of my stationary points. So that's sort of going to be in here and here. Okay, probably the last thing is to classify them. Now, if it's coming up here and turning around there, this is obviously going to be a maximum, and then we're going to go off to a minimum over here. But let's just do it for the record. So if I differentiate that again, when x is the positive one here, this will be positive. And when we're here, that'll be negative. So this will go to a minimum, and this will go to a maximum. That's pretty much all we really need to do. You might want to find the value of the function at these points, but to sketch it, I don't really think you need to do that. So it's going to go up here like that. Turn around, turn around. Oh my goodness. Smiley face not included. Okay. So you probably should label these things. So this is negative, root 2 on 3. This is positive. Okay, so let's check. If I rotate the graph, it looks the same. It's got the same kind of shape. Whoa. Okay. So that's my sort of freehand way of doing it. So let's go back to GeoGebra. Did somebody say GeoGebra? And see another way to do it. So let's say oh, hang on, that's the wrong one. This is it here. So there we go. Okay, so that's kind of what the graph looks like in GeoGebra. And you can see, yep, it's a bit nicer than hand drawn, but it's got the critical points. It's got the same intercepts, and it's definitely an odd function, because if I rotate that 180 degrees, then you get the same function. Okay, so they're the basic ideas of curve sketching for that particular example. But let me show you another one, because sometimes students they like to use calculus when it's actually not necessary, right? You can sketch a lot of functions and their graphs without using calculus. Okay, so let me show you what that might look like with the next example. Okay, so here's a good example. I think what a lot of students would do here is immediately go, oh well, I can't divide by 0, so x equals -1 is a horizontal asymptote, and then they would take some limits and stuff like that, right? But there's actually an easier way to do this. This is neither odd nor even, right? So Serena, this sort of goes to your question about what would it be if it's neither odd nor even. Well, this is an example here. Okay, so what I'm going to do is actually relate this back to something we already know. So what I'm trying to do here is this thing where we're shifting simple curves around. Okay, we start with something that's, quite difficult, and we're going to do some algebra, and we're going to simplify it down to something that we know. Okay, so what I'm going to do is I'm going to play with the numerator. Okay, and I can write it like that. So all I've done there is I've added 1 to the top, and I've subtracted 1, and I'm trying to get something like x plus 1 in the numerator. Okay. So I've got it. What I can do now is simplify. Now, why would you want to do that? Well, this is an easy bit, and this is an easy bit to draw. Okay, so instead of doing calculus on this, we can just basically use these two parts and simplify and move them around, right? So what we would like to do is I'm going to sketch the curve -1 on x. So that's a bit like this. So we'll forget the 2, forget the 1, right? And then so if you sketch that curve and you move it 1 unit to the left, you get that curve. So how can we go, let me know in the chat, from the graph of this to the graph of this? What might we do? You can tell me. So if you know the graph of this and you want to get the graph of that, what can I do to this the graph of this? Yes, Zhonghua, Aria, 2 units up. Okay, so the last step, that's it. Yes, Abdul Rahman, thank you. So let me just sort of put this back into perspective. You don't need calculus for this kind of example, right? If you can break it down to simple curves and move them around, left, right, up, down, then it's fine. Okay, so let me show you what this looks like with GeoGebra. Come back to GeoGebra. Yeah. Okay, so here's the graph of -1 on x. You can see there's a horizontal asymptote, which is the x-axis. There's a vertical asymptote, that's the y-axis. Now let's move that to go from this graph to this graph. We move it 1 unit to the left. If it was a +2 down here, we'd move it 2 units to the left, okay? So there it is. So you can see what's happened. The asymptotes have moved with it. So it's no longer a vertical asymptote at x equals 0. Now the asymptotes at x equals -1. Okay, so the asymptotes move with it. And lastly, let's move it up 2 units. So you can see now the horizontal and the vertical asymptotes have shifted. The horizontal asymptote is y equals 2, and the vertical asymptote is still x equals -1. Okay, so there is the graph. You just the thing I like about this is that it's super simple and you don't have to differentiate anything. You just start with the simplest form, shift it, that's it. Okay, and you can clearly see the asymptotes from here. You can definitely see that x equals -1 is a vertical asymptote, and y equals 2 is a horizontal asymptote. And I bet if you did calculus, right, on the original function, it's not clear that y equals 2 is a horizontal asymptote. It's not clear. Okay, you've got to take the limits, of course, but it's not clear. Okay, so if I was drawing in this, you've got -1 and you've got 2, right? You can work out the intercept there, and the other one goes up like that. Okay, what's the intercept going to be here? Who can tell me in the chat? What's the actual y-intercept? Who can tell me in the chat? Yeah, it's going to be 1, Aria. Thank you, because when x equals 0, this disappears, and you've got 1. Okay. So I really like that because it's a super simple way of treating functions without calculus. You know, you don't want to use a sledgehammer when you're just cracking a nut. You know, you just want to, this is super, super easy. Now you might ask, Chris, well, how did you know to do this? Well, I was just looking to simplify the function, okay? And I was a bit angry because I wanted that to cancel with that, but it doesn't. But you can kind of make it, you can make it cancel in some sort of weird way, okay? All right, that's curve sketching example. Now, I've just added an extra bit of text here. We're only going to consider the graph of this function for x greater than or equal to 0. For x negative, this gets a bit funky. So I didn't really want to subject you to the, you know, the funkiness of this function when x is negative. Okay. All right. So now we've got another function, and this is, it's not, even though cosine x is an even function, e to the negative x is neither odd nor even, so it's not odd or even. Okay, so we're not going to get any symmetry based on the structure of odd and even functions. But how might we sketch the graph for this? Well, let's go over to GeoGebra and see what's happening with the graph, and then we'll see if we can justify what's going on. Okay, so over here I've got the graph of the function. Okay, and it's a bit hard to see, but you can kind of see, well, it cuts at y equals 1, and then it's negative and then positive, and if you zoom in a bit, you'll see that it sort of it's hard to see, but it goes positive and then negative, so it oscillates between positive and negative values. Okay, and what you can also see, hopefully, cosine x is just between -1 and 1, and this e to the negative x, it really drags that cosine function down, so that when you're dividing, the exponential function really dominates. There's a battle going on, right? And the e to the x dominates. Okay, so let's go back to our document camera. So when you look at it like this, you know that cosine, sorry, is bounded, and it oscillates between positive and negative. And this thing is always positive, okay? And so what you've got, this thing is going to really pull that cosine function down really quickly. And we saw that in the picture, okay? Now, who can tell me on the chat what is, hang on, let me just put something under this. That'll do. I keep drawing on my desk, so that's not good. Consider what is the limit going to be? Who can tell me in the chat? Who can tell me? What is this limit for this function? Who can tell me? Hawk. Yes, it is 0. Yes, Michael and Hulan and Serena. So we know that the function is going, the graph is going to sort of eventually have 0 as an asymptote, right? It just sort of oscillates around it. Okay. Also, when x equals 0, e to the 0 is 1, and cos of 0 equals 1. So we have a y-intercept here. So cos x changes sign, and e to the x is always positive. So we expect f to oscillate. Okay, so it oscillates, it goes to 0, and it starts at 1. So let's put all those things together and see if we can make a rough sketch. Okay, so it's going to go down here and then something like that. All right, that's my rough sketch. Okay, if you think of these as waves, the waves are getting smaller and smaller as we tend to the right. Okay. Now, a good question here is, well, how is this going to work with, assessment and stuff like this? Remember, in this course, you're not doing anything by hand, right? So what you might want to do is to look at the plot command in MapleTA. So let me just see if I can pull that up for you. I just need to log on to the log on to Maple and show you a little bit about how you might do this in Maple. So just bear with me for a second while I load everything up. And then we can have a little look. Let's see how long it takes. So just bear with me. You know, one of the advantages, of course, of using Maple in your exam is that the pressure is off when it comes to, sketching or drawing, stuff like that. And some people really like that, right? Because curve sketching is not easy. Okay, so it's just coming up now. Okay. So let me just share my other screen and we can do this. Yeah. Okay, so the first thing that you're going to want to do is load up plots. So it's like called a calling sequence. Okay, and these are all the plots that you can do. Okay, so let's have a look at plotting the function that we just looked at. If you're not familiar with all the commands, you've got this sort of common symbol thing over here. Let's go off to, I don't know, like let's say 100 or something. Okay, so let's see what that does. Okay, so let's go down to 10. You don't even have to specify it, right? What happens if we just let Maple decide? Okay, well, we definitely wanted it, but x equals 0. Let's say 5. Okay, 10. There you go. Okay, so that gives you some idea of the plot command, right? And let's say we were doing The previous question, let's say it was, what was it? It was plotting 2 times x plus 1 all over x plus 1. Let's see what Maple does with that. Okay. Oh, how nice. It's even put in the vertical asymptote for us. Oh, isn't that nice? It hasn't done the horizontal one though. Okay. So the plot command is great. You'll notice that I use GeoGebra a lot in lectures, but you know, the reason I like GeoGebra is it's pretty intuitive and the commands are pretty easy to follow, right? With Maple, you know, obviously you need to load it up and do all those sorts of things. All right. All right. So let's go back and I'll just share my GeoGebra again. So who can tell me, so we finished with the lecture slides now. So who can tell me, okay, who can tell me on this chat, is this an odd function, an even function, or neither? Who can tell me? Is this an odd function, an even function, or neither? All right. It's neither. There's no symmetry. You're absolutely correct. What about this one? Oops. Let me just see if I can do that. Is that odd, even, or neither? Yes. Yes, I can feel the learning occurring. What about this one? Let's have a look. Is that odd, even, or neither? It's definitely odd, right? What about this one? Odd, even, or neither? That one's neither. Okay. Loving the chat, people. Loving the chat. All right. I'm just going to turn everybody's microphones and cameras on. That's all I really wanted to talk about in today's lecture, but we have a few minutes. You can ask me anything in the final 8 minutes. Do you have any questions, comments, observations? We finished a little early today, which is kind of nice, right? So you can switch on your microphone, switch on your camera, ask me anything. You got 7 minutes before the end of the lecture. So what would you like to talk about? I've been enjoying the week, the Freedom Week, although some people did point out, Nicholas, that if you live in Sydney, you actually cannot leave, like Sydney. You can't actually go to another state or another country. So we're not quite sure how Freedom Day is really working out. Yeah, so things have been all right, but unfortunately, I can't really go anywhere. All right, people, come on. There's 50 people here. I'm hoping international travel starts again soon too. Where would you go if you could travel? Let me know in the chat. Where would you go? Or you can turn on your microphone and say hello. Steve would come to campus. Nice. Yeah, I would too. You know what? I was in my office yesterday. I actually went into my office on campus. I had to get special permission, and they only gave me permission for 1 hour to be in my office for 1 hour. And I had to wear a mask even when I was inside, and I had to be double vaccinated. It was really weird because I haven't been in my office for like at least 4 months. So it was weird. Yeah, really weird. Yeah, Scandinavia sounds nice. A bit cold, but yeah, it sounds nice. Well, I hope everybody can come to campus soon. Um, I guess some students here have never been to the UNSW campus. Is that right? Let me ask. I have been to the UNSW campus. Let me know. Has anyone ever been? Oh my goodness. Never been to Sydney, Abdul Rahman. Oh yeah. That's sad, isn't it? Yeah, virtual campus, Aiden. No, Peng, I hope so. I think that's the plan. The plan is to get everybody back by term one, but also have online options for those people who can't be here. So, yeah, yeah, Carl. I think that's the plan. That's what the university is planning, to go back to campus in 2022 term one. That's what everybody's preparing for. Oh, Aria, it's hard. Pure and applied math is difficult. You know, I'm trained as a pure mathematician. I did my PhD in pure math, and when I started working at UNSW, I worked in the pure math department for like a year. And then the applied math department said to me, "Hey, Chris, do you want to come and work for us? We'll give you a promotion." And so suddenly I became an applied mathematician. And so that was 20 years ago. So I'm kind of a bit pure and a bit applied, but I think ultimately you should just do what interests you, whether it's really applied mathematics or really sort of freaky pure mathematics. It's up to you. Yeah. So hopefully, I mean, hopefully, well, you can do both. Do both. Yeah. Yeah. You don't have to choose. Do both. I think that's pretty interesting. So Aiden, does that mean you haven't got your vaccine yet? Hopefully everybody's can get their vaccine as soon as possible. I do have friends overseas who have had really hard time getting a vaccine. Um, they feel like they're like the last on the list. So I hope everybody can get vaccinated. Oh, Bill, hello. I finished the lecture early, Captain Bill. I hope that's okay. Um, I'm just asking people if they've ever been to the campus. 23 people say no, never. 9 people say yes. So, and I was saying, Bill, that I got to go into my office on the campus yesterday for 1 hour under strict supervision and guidance. Yeah.
Well, I did a similar thing at the beginning of term to get my notes and whatnot but I had a 15-minute window for it.
15 minutes. Oh my goodness. Yeah, I had an hour, and it was really weird. It was like walking into a time capsule.
Yes.
Let me just turn that back on. Yeah, so yeah, I'm hoping everyone can come back for term one. You know,
Just
um,
setting up my camera.
yeah, no worries. So we've just finished curve sketching, and we had about 5 minutes at the end to just chat, just shoot the breeze. And most people have done quite well in the test, Bill. At least they feel like they did all right. So Yeah. Anyway, I'm crossing fingers for everyone that they, hopefully I'll get to meet you one day, maybe next year. That would be really cool. You can, come and see me on campus or something. That would be awesome.
There we go.
All right, Captain, our captain.
Yes.
Where are your dogs today, Bill?
Let's see if I can. Right. So this one here.
Oh,
this one that I showed the other day, I think. This one's Benjamin.
Nice.
And then I'll get the other two. Okay, where are you? Here's our little girl, Bliss.
Nice.
And then I'll find the old one, the first one. And this one here is Biggles.
Biggles. So
name him.
do you ever dress them up in like flying paraphernalia with Biggles? I'm expecting the goggles and the scarf and the little strap down helmet.
Yes, exactly.
Oh well, looks like this. Yeah.
No. Continue.
Oh, I was just saying I've got a poll up for Bill's doggies, and it's probably the most interesting poll of the day. So, all right, folks. Well, if there's no more questions, I'll sign off and hand you over to the captain. But if you haven't done lab test 1, don't forget about it. You have to finish the test by 5 p.m. Sydney time, not start the test and not finish. And I think the writing assignment should be coming out soon, Bill. I think any day now, the writing assignment should.
Yeah, I believe it will be. Yes.
And it's flexibility week next week, so I won't see you next week.
Neither will I.
There's no lectures and no tutorials.
Yes.
Okay, so I'm just putting that in the chat. I know I'll miss you. I know there's something in my eye. I'm a bit sad, but I will sign off. I'll see some of you at the tutorial later on today. Over to you, Bill.
Okie dokie. All the best, Chris. Thanks very much.